if we want to get the moment and curvature for just one imposed strain at the top of the beam, what we will have to do is first to call this function plot beam and slices, and we set a top strain, and then we call our function get moment and curvature. So I will put a pause here so that my code runs only until line 40. And if I run the code, we can see here in the right the value of moment, which is like 2000 keep fit. And I can check also the curvature, variable curve, which has this value. But the idea is to create a plot using these outputs, but for different top strain. So in the next step, what I'm doing is creating a vector that will have different values of top strain, from this really low value to this value which is close to 0.003, and I will have 5,000 elements. Now I will create these three variables. These all of them initialize as 0, and each one of them will save here the moment for each one of the imposed strains at the top, the curvature for each one of the imposed strains, and the inertia for each one of the imposed strains. So I just create a loop over this vector. I run over all these elements, and I calculate the current strain at the top, and then I call my function get m and curve, and then I will obtain my values of moment, curvature, and also inertia. And then each one of these values are stored into each one of these vectors, m, curve, and ix, so that at the end I can create a plot. I can create a plot with the curvature against the moment, with the top strain against the inertia, and also the top strain against the moment. So let's run this code. Let's run this completely. And okay, I think that the most important plot is this one, the moment curvature diagram. So we have the units 1/inch and keeps fit. As you see here, we have a weird interaction where the concrete breaks, because when this happens, what actually is happening is that we increase the curvature, but the moment slightly reduces, just for a moment. And then it again starts increasing. So this can give you some problems later when you are trying to find rotation and also displacement. So what you should do is that once you have these values, you can create a small filter just to use a line here that connects the point here to the point here that is greater than this one, so that you will have a small line, an increasing line from this point to some point here, so that you won't have problems there. But for now, it is interesting to see this interaction. We have here the part where the concrete is elastic, uncracked. Here we are in the zone where we have the concrete cracked, and the steel is still elastic. In this part, the concrete is starting acting as nonlinear, and then at this point, we also have the yielding of the steel, which later produces this big increase in curvature.